So, now that we have several possible methods of solving quadratic equations, we're going to look at some applications, some word problems that we're going to be solving by coming up with a quadratic equation and then solving that equation using whatever method seems easiest. So, let's start in with some examples. The length of a rectangle is 5 centimeters more than the width. The area is 66 square centimeters. Find the length and the width. So first of all, notice what we're trying to find here is the length and the width of a rectangle. And we're talking about the area. So you have to know that for a rectangle, the area is just the length times the width. So we're looking for two numbers that when you multiply them together, you get the area, which is 66. We're trying to find both numbers, and what we know about them is that the length is 5 centimeters more than the width. So if the width is, say, 2, the length would be 5 more than 2, which is 7. If the width is 3, the length would be 5 more than 3, which is 8. If the width is 20, the length would be 5 more than 20, which is 25. So whatever the width is, the length is that number plus 5. So I could just let x stand for the width, and then x plus 5 would stand for the length. And then the area, which is what you get when you multiply those two things together, is 66 square centimeters. So that gives us our equation. X plus 5 times x equals 66. Now I'm going to go ahead and multiply that out and get x times x, that is x squared, plus 5 times x equals 66. So there's our quadratic equation. It's got x squared in it. Now I want to get everything on one side equal to 0 on the other side. So I'm going to subtract 66 on both sides. That gives me x squared plus 5x minus 66 equals 0. Now we got to solve this, and I think I can see how to factor that. So if I can do that, then maybe the easiest way to solve this one would be by factoring. So the two factors both start with x times x to get x squared. They would have to end with numbers that multiply to negative 66, and those numbers would have to add up to positive 5. So the factors that do it are x plus 11 times x minus 6. If you FOIL that, you get x squared minus 6x plus 11x, so there's your plus 5x, minus 66. Now that we have it factored, each factor gets its own equation where it gets to be equal to 0 all by itself. So x plus 11 equals 0, or x minus 6 equals 0. And that means x equals negative 11, or x equals 6. Now both of those numbers work in the equation, but only one of them really makes sense as the width of a rectangle. The width would have to be a positive number, so the one we want is 6. So there's our answer that the width is 6 centimeters. And careful, we had to find the length and the width, so we're not done until we say what both of those things are. The width is 6 centimeters, and then the length would be x plus 5. So 6 plus 5 would be 11 centimeters. And now we are done. We have the length and the width. We've answered the question. The length is 5 more than the width, and the area, the length times the width, does give us 66 square centimeters. On to the next example. The difference between the square of a number and 3 times the number is 28. Find the number. So this is kind of an abstract description of some unknown number that we have to find. So let's translate from those words into an equation. The difference, okay, that means subtraction. That means one thing minus another thing. So what's the one thing and what's the other thing? Well, the one thing is the square of a number, that number squared, and the other thing is 3 times the number. So x squared minus 3 times x is, so there's the equal sign, 28. So translated into an equation, that looks like the square of the difference between the square of a number and 3 times the number is 28. X squared minus 3x equals 28. That's the equation we have to solve. Let's subtract 28 on both sides, and we get x squared minus 3x minus 28 equals 0. That I can solve by factoring, because I can find numbers that multiply to negative 28 and add to negative 3. So the factors are x minus 7 times x plus 4. X squared plus 4x minus 7x gives you the minus 3x in the middle, minus 28 when you get the first and the outer and the inner and the last. So now, separating the factors, x minus 7 equals 0, so x equals 7, or x plus 4 equals 0, which means x equals negative 4. So it turns out that there's two possibilities for what the number could be. Could be a positive number, could be 7, or if you're allowing for it could be a negative number, negative 4 is a possibility. So it didn't say that the number had to be positive or had to be a specific kind of number, so I would give both of those. The number could be 7 or it could be negative 4. Okay, next example. A rock is dropped from a tower that is 225 feet tall. The height, h, of the rock after t seconds is given by h equals negative 16t squared plus 225. When will the rock hit the ground? By the way, this is an equation or a formula from physics that talks about, well, it's pretty accurate for something like a rock that's just falling through the air, subject to gravity. It's not as accurate to something like a feather or a piece of paper or a frisbee where the air resistance has an effect on how fast it falls. But we're just going to take this equation and we want to find when, that is what time, how many seconds, what t, will the rock hit the ground? Okay, hitting the ground means that its height above the ground would be 0. So we're going to put 0 in for h and then figure out what t has to be. So negative 16t squared plus 225 equals 0. That's the equation we have to solve. Now, because there's a t squared but no other t term, I think the easiest way to solve this would be by taking square roots. If we can get the t squared by itself on one side of the equal sign equal to just a number on the other side, then we can go from t squared equals a number to t equals plus or minus the square root of that number. So first I subtract 225 from both sides. Negative 16t squared equals negative 225. Then divide both sides by negative 16. So t squared equals negative 225 divided by negative 16, which comes out to be positive 14.0625. So that's t squared. Now we use the fact that when something squared equals a number, the something equals plus or minus the square root of that number. So t could be the positive or negative square root of 14.0625. And that, my calculator tells me, is 3.75. Now the equation actually has two solutions. For the equation to be true, t could be positive or negative 3.75. But only one of those really makes sense in terms of the situation that the problem is talking about. So the one that we really want is the positive number, the one that's how many seconds after the rock was dropped. So that would be 3.75 seconds. Okay, next example. If the sides of a square are increased by 5 meters, the area becomes 100 square meters. Find the length of the sides of the original square. So let's see what we're dealing with here. We have a square. We're trying to find the lengths of the sides of that square. Since it is a square, they're all the same side as one another. We just want to know what that is. We'll call it x. So the original square is x meters long on each side. Now, if the sides are increased by 5 meters, that makes them all bigger. So now they're x plus 5 meters long. And with that new bigger square, the area becomes 100 square meters. So the area of a square is just any one of the sides squared. For a rectangle, it would be length times width. But for a square, those two are the same as each other. So you just take that number times that same number. So the area, x plus 5 squared, is equal to 100 square meters. There's our equation. Now, the way this is set up, I think it would be easy to solve it by taking square roots. When you have something squared equal to a number, the something equals plus or minus the square root of that number. So x plus 5 equals plus or minus the square root of 100. And the square root of 100 is 10. And since we are talking about sides of a square, it only makes sense for that to be positive. So that's why I just put the positive square root. So x plus 5 equals 10. And now we were trying to find the length of the sides of the original square. So subtract 10 on both sides, we get x equals 5. So that's the answer. The sides are 5 meters long. One last example. If the cost C for manufacturing X units of a certain product is given by C equals x squared minus 15x plus 50, find the number of units, that's the X, manufactured at a cost of $9,500. So if we put $9,500 in for C, then we're supposed to figure out what X has to be. So x squared minus 15x plus 50 equals 9,500. And I'm going to subtract 9,500 on both sides, and I get the equation x squared minus 15x minus 9,450 equals 0. So that's the equation we have to solve. We might be able to solve this by factoring, but it would be kind of tricky. We'd have to think of numbers that multiply together to give you 9,450. So instead, this time I'm going to use the quadratic formula. So I'm going to be plugging in 1 for A, negative 15 for B, and negative 9,450 for C. So x equals negative 15 plus or minus the square root of negative 15 squared minus 4 times 1 times negative 9,450 all over 2 times 1. So when I do the calculations, negative 15 is just 15. And 2 times 1, of course, would be 2. And the part underneath the square root sign, well, that was negative 15 in parentheses squared minus 4 times 1 times negative 9,450. And that came out to be 38,025. And then the square root of that number, the square root of 38,025, is 195. So we're looking at 15 plus or minus 195 plus 2. The one we want is the plus, because if we do the minus, we'll get a negative number. And it doesn't make sense to have a negative number of units produced. So 15 plus 195 divided by 2, and we've got to divide the whole thing, not just part of it, by 2, does give us 105. So that's the solution. That's the number of units produced.